My name is Andy. If you've checked in, you've probably met my clone. I'm the same person. It's me. Okay. Context is all you need. It's a name that I took a while to set. It makes an idea to attention is all you need. How many people from here heard about it? Okay. The most people. Cool. Attention is all you need was something that revolutionized the way AI models work. And I try to find something that we need right now, in order for our AI models to do what we want and what we needed for what we need from them. Oops, that was okay. The first idea is that everyone has the same frontier models. For example, Codex, Opus, Sonnet, maybe Gemini. The model isn't the edge. That's what I found out. Not the model. There is like what you give it. Like the prompt is not the edge. What people tend to optimize is like doing better prompts, but you can only describe what you can. You try bigger context windows like Gemini, you try newer models, but the last three already passed the bar. And maybe you use fancier frameworks. But what actually matters from my point of view is the signal you feed in. This is something that a lot of people should connect to. You say to the model without any context, build me a login page, and the agent writes a login page. It doesn't see it. No, the button should be like on the left or on the right. Again, it rewrites it, but it still can see it. Still wrong, and you try to fix that, and takes a lot of time. So I'm gonna make a side-by-side here. Try to think that you are trying to onboard a human engineer in your team. Will you give him your design files or not? Will you let him see the running app or not? Will you like share the project specs or tickets with him? Will you show him your whole code base and will ask him to write any tests? What we are doing with our coding agents without context is we are not giving them any of this, and we expect them to like actually do what we want. That's impossible. At least from what I tried, this is what I discovered. Here I described 5 layers of context that I use like most of the time. So for visual, I use Playwright. It's like a MCP. It's a simple tool that connects to a Chrome browser. Basically, the AI model with Playwright can do anything in that page. It can open any website, even localhost, even your page, even can look into the logs. Basically, if you know what developer tools in Chrome is, probably most of you do, it has access to all of those, and it can actually see what's inside the page. So if you ask him to move the button to the right, then it will check to see if the button actually moved to the right. And now I'm going to go to the next one, because it's like not that as important as this one, but still is very important. You are doing some design. You maybe have that design in Figma. You need to give the agent the Figma file, because the agent can actually read the JSON behind that Figma file. And that's amazing. When I've tested that the first time, I was like, oh my God, how didn't I knew about that until now? The next one is product. Here I written GitHub linear docs. Probably other people from here used other tools like Jira, Trello, whatever. This is like telling the model what you're building. One thing is to like to give the model the actual ticket to look inside it. Is not enough to give just a copy paste, because inside that ticket there are references to other tickets. Maybe someone else tried to fix that. Maybe it was fixed some time ago, but it reproduces again. So giving it the context, it's like another level. Maybe it basically sees like the whole history of that ticket, the references and everything like that. Now for Codebase, it's really useful for the model to be able to code search in your repo. For example, what I do is I usually create one folder on my computer called like the company name that I work in. And inside that folder, I basically check out all the repos or start the new repos. So it basically can search inside that company folder. I explicitly tell it to go and look and check and look and try to like see how our code looks. You need to respect some patterns. Maybe you have an open API JSON somewhere. Why not read it directly? Because I don't know, for example, Cloud Code can read it like very specific. it will not go to actually read the whole OpenAPI JSON. It will basically go and search inside the OpenAPI JSON and get exactly what it needs from there. And correctness about tests. This is something that before AI, we didn't like reason too much, but now it's much more simpler to write tests and actually ask the model to pass the tests. A real task that I actually implemented like last year was to implement a billing dashboard. The first thing I've done, and I saw that actually works, is have a Claude MD. I use Claude Code, but for other people, might be Agent MD or something else, maybe some cursor stuff. Inside that Claude MD, what I do is basically it's a living document. You don't just create it once and that's the final version. Because if you leave it like that, it will like only know what the initial research agent did. You basically need to tell the agent, add that scenario to Claude MD, add that to memory, add that specific case to the memory. This is something that also Boris, that created Claude Code from Anthropic, does. They actually in the team have one Claude MD inside the Claude code base, and the whole team updates it. But it has updates like many times in a week. Now, going next from Claude MD, you ask it to read the API specs. You can say to check if you're doing you are migrating some legacy things. Did that? This real task was from something like this. You ask it to actually look at the old system, then to write the code, then use Playwright for a front end to actually open the browser and check what it does, fix the logs, etc. And this is a loop. It basically fixes, verifies, and repeats. No human in the loop. CodeMD is basically what triggers everything I do. This is like the first thing that I set up in any project. And as I said before, it is like a living document. So if you update this file, you are basically doing like a lot of things already. But if you combine CloudMD with the other things that I said earlier, you basically write code, Playwright opens the app, it checks what it did, it compares with the spec and or the design, it reads the error logs, it fixes it, and then it repeats until the task is actually done. For example, I had loops for 5-10 iterations with 0 messages like from myself. It basically did 5 to 10 iterations. I was just looking at Claude Code and it was like fixing. It basically fixed somewhere between 5 and 10 things. Not 5-10 bugs, but it did 5-10 iterations that it fixed like multiple bugs and layouts in that. And the agent is not waiting for you anymore. Basically, you are not the bottleneck anymore. How I work with multiple agents, this might be something interesting too, is that I usually, some people use it some other ways. This is how I use it. I usually open an agent for one of the repos. For example, for the API endpoint, let's say I open one agent, I open I may open a second agent for the front end, and I open a third agent for the billing. And I basically talk with them in parallel and prompt them in parallel. And when something needs to be shared between the two, I'm basically the buffer. So when agent one says something like I've finished implementing the endpoint, I can say to agent to start implementing the frontend because the OpenAPI JSON has been modified. This is how I work. I'm still the buffer here because you can do even greater things than this, and this could be also automated, but this is how I work. I didn't said initially maybe, but I am an engineer and I like what I do. So I want to be the person that's inside that loop. Just that I don't want to like spend time like saying to it, move that button 5 pixels to the right. I think to the end, I'm not sure. Yeah. How many minutes do I have? Okay. But you said 5 earlier. Okay. I gave here an example. For example, don't touch the common package. Another agent is working on it. I did that manually. This is how I work. And this is how I felt that is a good way of doing it for myself. So it was basically the same feature. It was what there were like 3 agents, and I was like the router. This is how I named myself here in the presentation. Now, one of the let's say questions that I get a lot of times, and also was a couple of times in the WhatsApp group, was like, what do you do when the context resets? You will lose everything. And I can tell you, you will lose everything because when the contexts happen, the actual summary of your whole conversation, which is like huge, the conversation is huge. When you compact it, it's like this. If you read the compaction of your conversation, you will be amazed how much it loses. So what do you do? Because you ideally want to stay in that conversation forever. It's not possible. There is a limit to the actual model on each iteration. So what I do is basically it's something very simple. Before I see that it nears like the completion, the limit of the context, like maybe 80%, 90%, sometimes the model says that I'm nearing context. We need to do something right now. We also have the Claude MD specialized for me. We can chat about this. Let's see if I still have time. But the Claude MD that is inside the organization, I have a Claude MD in the organization level. I have a Claude MD in every repository level. Sometimes in the subfolders, I have a separate Claude MD. And I ask the model to update the specific Claude MD that makes the most sense for the actual gimmick that the model like hit. It will hit a lot of problems and there will do some stupid things. You tell it, write that stupid thing to the appropriate Claude MD. And it writes it, and then it will never happen. Like never. Maybe, I don't know. If something happens in some, you are like reaching context, you are 98%, 99% maybe, it might lose that information. But I never let it reach 99%, and I don't do auto compaction. When it is like 80%, 90% of the actual context, I basically save all the important things we discuss here, X, Y, Z. Sometimes I don't even tell it what to save because it will figure it by itself. The last models are really smart and are like amazing. From Opus 4.5, there was like a shift. There was like a big shift. Opus 4.6 is like 4.5 plus. I basically explained everything that I wanted to say in this slide. The pre-compaction saves, I didn't actually knew how to write it in order for you to understand. This is why I explained it. So the pre-compaction saves are not automatic. I do them manually. So every time I near compaction, I tell it to actually update the Claude MDs. My Claude MDs are updated daily, hourly, a lot of times. Sometimes I don't need to update them. You will see that in the first times you don't have Claude MDs, it will make a lot of mistakes. But once you reach like a certain level, it will make less and less mistakes. So sometimes you don't actually need to update them, but you still need to update them because if you leave them as they are, they will like influence what you do in the future. Like maybe not tomorrow, maybe not next week, but maybe in a month or so. Git history is also important. Tests are also like very important. Tests are very nice because you can give the model like a machine verifiable definition of done. It basically knows that if the tests pass and are green, the feature is done. And it can iterate like for a long time. Older models from like last year, they were not like iterating too much. They were like stopping to, I don't know, whatever, why, I don't know why. But the current models can actually run and run and run and are like very, very trained to, I need to get it done. I need to get it done. This is how they are trained. Git history is also important. It really depends here because of your Git history. We can chat afterwards about Git history. And everything that we talked about now, the compound effect of everything that I talked about until now is basically like a different category. And this category is something that you all heard. It's named context engineering. I had one more slide, but I think we can, are you sure? Yeah, okay. Yeah, I have my opinions. Yeah. Yeah. So this is like opinionated. The next presentation will be like about the specs first. You will really like it. My approach is explore first. The idea is like not to make the spec like the holy grail, like I wrote the gospel here. I take spec as a reference because I don't trust the spec. I actually trust what the agent explores first, because the spec can say something, but your code base says something else. Sometimes product people don't understand why. So I prefer to actually explore, always explore. And this is like the first thing I do in every new conversation. Let's say you start a new project. The first thing I do is ask it to explore. Search the web, search GitHub. How did other people solve this? You don't go to that empty chat and you say, build me a $1 million business. No, you ask it. What do people do in order to make a $1 million business? And you will figure it out. It's not a coding problem. It was never a coding problem, and it will never be a coding problem. That's completely something else. Claude MD or no Claude MD, I think everybody understood that I'm a Claude MD fan. when to intervene. I like to be in the middle of these loops. So usually the agent asks me, this is how like I've written my code MDs to not stop until it actually needs some real feedback. About the parallel agents, I already talked. I use 3 to 5. I don't actually do more than this. I feel like I get extenuated if I do more than this. And what's not worth automating? The architecture decisions always, because like I'm an engineer and I want to be like in control of the architecture. Context is all you need.